Excellent. Okay. Yeah, so thanks again for coming in today. Like I was just saying, what I'd like to start with here is just a discussion about how data storage and image analysis has worked in the HCBI in the past and what we're looking at doing in the future. Great. So back when I joined the HCBI, so this was back in 2013, that was the days of low data volumes in microscopy. If you had a data set that was over a gigabyte in size, that was considered pretty big. And so we had this standard setup where we had a microscope. It was hooked up to a computer. And that computer had, I think at the time, they came with about 2 terabytes of storage, and that seemed like limitless storage. And after you're done your experiment, you plugged in, even back then, it wasn't even external hard drives, it was just little USB thumb drives, and took your data with you. And this worked well. There was nothing wrong with the system. Everybody was happy. Until a little bit later on in 2013, this microscope showed up. So our light sheet microscope, our first light sheet microscope. And all of a sudden, we were able to gather a terabyte of data in only a couple hours. And so this, as you can imagine, posed a lot of problems. But at the same time, it came with this interesting solution. This was something that was certainly novel to me at the time. But it was this 2-computer solution. So what you had was your microscope, and it was attached to a computer that controlled your microscope, but none of your data was actually saved there. The data went off to a second storage computer that could sit beside it. It could sit in another room. It didn't matter. But this computer would have a large amount of storage on it. So the first one we got was actually 12 terabytes. And these were connected by something else that was new to me, was optical fiber. So this was a 10 gigabit connection, which allowed you to move data pretty fast. So this moves about 600 to 800 megabytes of data per second. So it's pretty quick. And that meant that as the data was coming off the dual cameras on the microscope here, it could be sent straight to this computer. 12 terabytes sounded like an enormous amount of data when this computer first showed up. But we actually had this microscope on a demo. It was in the Zeiss demo room across the hall from the HCBI for about 3 months. And we actually filled up that hard drive twice during those 3 months. So we realized that this was still going to be incredibly insufficient for what we needed. So this raised a few problems. One, the obvious one, was that 12 terabytes was not enough storage. And this was only one microscope. We had over 10 microscopes in the HCBI, and we only had one of these workstations that could act as sort of a storage buffer, a storage station. The rest of the facility only had 1 gigabit wiring as far as our networking in the facility. So even if we were trying to transfer large amounts of data from one of the other microscopes to this computer, it would take forever. And of course, as users, if you wanted to process your data, you had to come into the HCBI and be here physically to do that. And this problem only got worse after that point. So we started having these sort of high throughput microscopes come online. So now we've got actually 3 of these Axio scans, the 2 here in Cambridge, 1 in Alston. We have the Cell Discoverer, which can image a 96-well plate in a couple hours. And we just had this brutal data handling structure where you'd image on here, you'd dump it onto a hard drive. Sometimes this could take hours to transfer it onto your hard drive. Then you'd move over to one of the workstations and you'd have to transfer the data again there, which would take forever. Then when you're done analyzing your data, you had to put it back on your USB hard drive and get it out of the facility to wherever you needed it. And unfortunately, this is actually how a lot of you, I think, are still operating to this day. So this is not certainly something that's in the past. This is still, unfortunately, somewhat common. And sort of in this same time frame, the 2013 to 2015, you folks started doing some incredible experiments. So, I mean, here's just an example of 3 papers that were underway during this time. And these 3 papers alone um, created almost 200 terabytes of data. So, um, and obviously there's not just 2 groups or 3 groups using the facility. So the amount of data that we're now creating is quite extensive and difficult to deal with. So in 2015, we sort of sat down with research computing and tried to come up with some sort of structure that would allow us to handle all of this data. And so this is kind of where we're at right now. Essentially, all of our microscopes obviously have an acquisition computer that's hooked up to the microscope. That's what you interact with while you're acquiring your images. And then also on site here at the HCBI, we have these high-end processing workstations. So those are the ones that sit outside our offices here in between the poster printers. So the microscopes can stream data directly to these. We rarely do that. We basically do that in the case of the ELIRA and the light sheet. But more often what's happening is we're acquiring data locally on these computers and then either transferring it to a USB drive or sending it to our dedicated storage server. This, what you're probably all familiar with, CBS Store. This is shared between us and the Center for Brain Science. And this, what you may not know, this actually lives downtown. So this is above Macy's in downtown Boston. And so also at the time when we were setting up this storage server and expanding the number of workstations, so we're up to 6 now in the facility, we also rewired the facility. Well, we didn't rewire it, we refibered the facility so that the entire facility here in Cambridge has 10 gigabit optical fiber connections between not all of the computers, but anything that's going to generate a reasonable amount of data. So this now allows us to move data around here in the HCBI fairly quickly, which is great. We can send it to our shared storage server. I know most of your individual labs also have storage through research computing, although these are limited because that's often a much slower connection. It's usually a 1 gigabit connection. And then we also do have the ability to transfer from our storage server to the Harvard cluster, which lives way out in Western Massachusetts in Holyoke, if that's needed for an experiment. And then just recently, thanks to COVID, we've actually now made these workstations remote. So you can remotely access those through TeamViewer. So what's wrong with this situation? Still a lot of things wrong with it. So our 400 terabytes of storage isn't enough. Like I showed you 3 papers that used half of that. So we need more storage. There's another issue that our storage server is it runs what's called a Lustre. So it's a Linux-based operating system. And all of our computers here obviously run Windows. And what that means is that you have to do some sort of translation of those files to convert them from Windows to Linux. And that slows down our transfers. So it actually means that we don't realize the full 10 gigabit bandwidth that we have between our workstations and microscope computers here in the HCBI and that storage server downtown. Like I said, still many of you are still using USB hard drives. We're constantly moving data around. I know a lot of your data gets copied 4 or 5 times. It's in 4 or 5 different places, which uses up a lot of our storage space. We're constantly having computers that are filled and that crashes an experiment in the middle of an experiment. There's some security issues, obviously, with plugging in all these external hard drives. And with TeamViewer itself, I've had lots of fun interactions with Hewitt discussing whether TeamViewer is safe or not. And there's also financial costs, which are actually fairly substantial with TeamViewer. And finally, although we can transfer data back and forth between our storage server and the cluster, it's not a streamlined process. It's not easy. So there's some pretty poor integration there. So for this has really honestly been 2 years. Oh, sorry. And the last big issue is this. Aside from Fiji, ImageJ, all of our different workstations run different modules or different software packages, which means you're often restricted to one workstation. And some of the workstations that have more options than others are really heavily used, whereas other workstations just aren't used at all. So this is another big problem that we have right now. So for the last 2 years, I've been thinking about this and working with research computing. And we outlined this major project, and we had 4 key goals for it. So what we wanted to do was we wanted to ensure that we had adequate amounts of storage and that it was expandable for future needs. We really wanted to limit and automate any data transfers that have to happen. We wanted to be able to provide easy remote access to image analysis software. So it doesn't mean that you have to come in and physically sit in the HCBI to do your image analysis. And we wanted to try and better integrate this data analysis and workflows with the Harvard cluster if you are in need of that or want to use that ability. So here's the big unveil. This is what we're hoping to move to. So I've kind of outlined this as 2 phases, a phase 1 and a phase 2. Phase 1, the hardware for this has hopefully been ordered yesterday or today. So it is on its way. I anticipate it'll be late spring, early summer before we actually start migrating to this. But this is what we're looking at doing in phase 1, and then there's also a phase 2, which is mostly a dream at this point. We'll see if it comes into play. But here's what we're hoping to do. So what we want to do is on site at the HCBI, all we are going to have in the future are just the computers that are hooked up to the microscopes. Zeiss now sells these. There's an upgrade, a 12 terabyte upgrade for each of these. So we'll slowly be doing that as we replace our microscopes. And so that means there's going to be 12 terabytes of short-term buffer storage in each of those. So if anything ever happened, that the network goes down, we can't transfer data, we've got quite a few days of bufferability here. So that's not going to be an issue if we have to short-term buffer stuff locally. But what's going to happen is when you do an experiment on one of these computers, sometime probably around midnight at night, these computers are going to automatically upload that data to our new storage server. And this storage server is not going to be in downtown Boston anymore. It's going to move out to Holyoke, Massachusetts. So it's going to go out to the MGH PCC big data center where the Harvard cluster lives. It's going to start out, it's going to be about 1.2 petabytes. And then, like I said, it's going to be expandable. It's also going to run a Windows operating system. So that's going to allow us to take advantage of this really fast network connection that we have. And then because it's living out there, it's obviously in close proximity to the cluster. So there can be a good integration and movement of your data back and forth if you need to do any processing on the cluster. And then what we're also going to do is we're going to put 10 workstations out there. And these are going to sit on the exact same switch as the storage. They're going to have a 25 gigabit connection. And what that means is that once your data lands on this storage, it never has to move again. So because of this connection, it's just like the storage server is essentially a hard drive on these remote access workstations. So we don't have to worry about copying your data and moving your data all over the place anymore. And these remote workstations are going to be similar to what we're doing now with TeamViewer, where you can just connect to one of these remote workstations. Okay. So if we look at this a little bit closer, they aren't actual workstations like what you're used to seeing outside in the HCBI. They're just server racks. So basically, and they're the exact same product from Dell. The difference is the server racks on the storage side over here are full of hard drives, and the racks on this side are full of graphics cards and RAM, essentially. So these are going to be really highly capable workstations. They exceed the specs of anything that we have right now here at the HCBI, and we're going to have 10 of those out there. And then as far as our storage goes, it's going to be divided up into 4 different bricks. Unfortunately, this is one of the limits of using Windows operating system, is that you can't make a 1.2 petabyte storage server. There's a sort of maximum limit in Windows. So we're going to actually have to break this up into 4 different units. And we'll just have data from specific microscopes on each one of those. So you'll know where your data is based on which microscope you use to acquire it. So during this phase 1, so what it's going to look like when you want to actually use one of these workstations, it's going to be very similar to our current process. So you're going to go into our reservation software in Spinal. You're going to reserve the workstation. You're going to connect to it remotely. We're going to move away from TeamViewer. We're going to be using Windows Remote Desktop Connection. And all of these workstations will automatically mount the storage servers, so you'll be able to find your data. And then what I think is really nice is we're going to move to a license server model for all of our commercial software. And this means that every workstation here will have equal access to the software licenses. So if you're using Arevis, it doesn't matter whether you're on workstation 1 or 10, you have access to the 2 or 3 or 4 Arevis licenses that we have. We're hoping that we're going to have Zen licenses for all 10 workstations and all modules of Zen. So if you're doing a Lyra processing, it doesn't matter which one of these you use. If you're doing Intellisys processing, it doesn't matter which one of these you reserve. As far as you're concerned, they're all going to be equal. The other thing that we're going to put in there, and this is something that we run into problems with often now, is people don't log out on the computers here, and then you end up having 3 or 4 user accounts open on them, and that leads to conflicts with the software. So these will have automatic timeouts. So if your session becomes idle, you forget to log off, it's going to do that for you. So that's what we're going to do to start with. Obviously, we anticipate 10 workstations is more than we have now, so we think this allows for some future growth. But at some point, it's possible that this sort of, we have more usage than can be accommodated on these workstations in sort of this reserving and Spinal ad hoc scheduling manner. So this is where I get to what I was talking about, the dream phase. And this is to introduce what's called a virtual desktop infrastructure. So this VDI kind of lives right here, positioned in between the storage and the cluster and these remote workstations. And what this would essentially look like is you'd spin up a remote desktop, and on that remote desktop, we'd have icons for all these different software packages. So things that are open source that are on the cluster, as well as commercial software packages that can only run in a Windows environment under limited licenses. And what would happen is you would go ahead and you would click on one of these icons, whichever software package you needed, and then there'd be a sort of decision tree that would run in the background. And so this VDI would say, okay, is this a software package that runs on the cluster? And if it is, it would request an interactive session on the cluster and open up the program there. And you'd actually be using cluster resources and would probably not even realize that's what you're doing. If not, then it's going to ask, are there any free workstations available? If they're not, it's going to put you in some sort of scheduling queue. And if there are, this should say workstations and licenses. If there are, it's going to connect you to one of those 10 workstations and open the software version of your choice on that workstation. So again, don't worry about this. It's kind of a dream at this point. Maybe we'll get there, maybe we won't. But we definitely are thinking about what happens if we do start to overwhelm things as far as scheduling goes. Cool. So in summary, this is what we're hoping to move to. We'll have those microscopes hooked up to all of our instruments here in the HCBI. We'll have a nightly automated upload that will send your data out to the storage server in Holyoke. And then from there, you'll be able to remotely connect to one of these workstations and do your image analysis remotely. And if you so choose, you can also integrate this with processing on the cluster. Great. So I am going to stop recording now.